Chapter 16, Section 2, Driving Force of Reactions. Some reactions need energy to occur and some reactions release energy when occur. So, what are the factors that affect whether a reaction will occur spontaneously or not? Spontaneously means does not need energy to occur. So, factors that affect whether a reaction will occur spontaneously. Spontaneously means does not need energy to occur. So the first factor is change in energy of reaction. If you remember from chapter 16, section 1, we talk about the energy of the chemical reactions. It's called enthalpy change. The symbol is delta H. So here, delta H, enthalpy of reactions. So the rule is reactions generally move to a lower energy state. To a lower energy state. So here, the energy of products less than energy of reactants. Also, if you remember, when the energy of reactant greater than energy of a product, it's an exothermic reaction and delta H is negative. So here it's an exothermic reaction, delta H less than 0 at negative. So most of the spontaneously reactions are exothermic reactions. Why? Because reactions generally move to a lower energy state. So most of the reactions that occur spontaneously are exothermic reactions. Okay, now what about endothermic reactions? Most of the reactions that occur non-spontaneously are endothermic reactions, but some endothermic reactions occur spontaneously. Some endothermic reactions occur spontaneously. In endothermic reaction, energy, if you remember, in endothermic reaction, energy of a product greater than energy of reactants. Delta H is positive. The rule is reactions generally move to a lower energy when the energy of a product less than energy of reactant. So why some endothermic reactions occur spontaneously? For example, melting of ice. If you have ice, it spontaneously melts to liquid water. Why? The energy of liquid water particles greater than the energy of water particles in ice. So why it occurs spontaneously? The difference between ice and liquid water, the arrangement of particles. So the arrangement of liquid water particles less ordered than the arrangement of water particles in ice. So here less ordered. So they found that there is a tendency in nature to proceed in a direction that increase the randomness of system. So this is the second note or rule. There is tendency in nature to proceed in a direction that increase the randomness of system. So again, most of the exothermic reactions occur spontaneously because they move to a lower energy, but some endothermic reactions, regardless the energy, they occur spontaneously because there is a tendency in nature to proceed in a direction that increases the randomness of system. So the second factor, the first factor is change in energy. It's moved to a lower one. And the second factor is the randomness of particles or of system. The symbol is delta S, which means entropy. So entropy, delta S, a measure of the degree of randomness of particles. The rule is delta S equal entropy or randomness of a product minus randomness of reactants. It's like enthalpy. Enthalpy means change of energy, and here delta S means the randomness of particles. So in which case delta S is positive. Delta S greater than 0. In which case it's positive when the entropy of products greater than entropy of reactants. So here increase in entropy, and this is for spontaneously reactions. In which case delta S is negative when the entropy of reactants greater than entropy of products. So randomness of reactants greater than randomness of products. So here decrease in entropy. So it's an spontaneously reactions. So the first factor that affect whether a reaction occurs spontaneously or not, the first one, the change of energy, delta H. It must be negative. So negative, it's for exothermic reaction. So if you get that the energy of products less than the energy of reactant, it's a spontaneously reactions. It does not need energy to occur. The second factor is the randomness of particles, delta S. When delta S is positive, randomness of particles for a product greater than reaction, it's a spontaneously reactions. An example of increasing entropy, for example, mixing of gases. If you have two gases and mix together, so the entropy increases. Entropy again means the arrangement of particles, so it becomes less ordered. Or when you dissolve sugar in water, or changing state from solid to liquid to gas. If you remember, gas particles, they are free to move, so they have random arrangement. And what about liquid? According to solid, they have more kinetic energy, they move freely, and according to solid, so they have less arrangement than particles in solid. So processes in nature are driven two directions, toward least entropy, enthalpy, delta H is negative, and the greatest entropy, delta S is positive. These two factors oppose each other. So which of these the dominant factor, delta H or delta S? So there is a function, combined enthalpy entropy function, the combined enthalpy entropy function is called Gibbs free energy, delta G. What is the rule for delta G? Equal change in enthalpy minus temperature times change in entropy. So here, change in enthalpy, and here temperature, it must be in Kelvin, and delta S for change in entropy. So reactions occur spontaneously when delta H is negative and delta S is positive. These two factors oppose each other. So to get which the reaction occurs spontaneously, you have to calculate delta G. It's called Gibbs free energy. So if delta G is negative, so it's a spontaneously reaction. If delta G is positive, it's a spontaneously reaction. So for example, or before examples, according to this rule, in which case delta G is negative, and in which case delta G is positive. Delta G equal delta H minus T delta S. So here, delta H, delta S, and delta G. What about if the enthalpy is negative and entropy is positive? What do you think about the sign of delta G? It will be positive or negative? Spontaneous reaction or non-spontaneous reaction? So when delta H is negative and delta S is positive, and here you have negative sign, so negative plus negative, the answer is negative. So in this case, it's always spontaneously reaction. Now, what about if delta H is negative and delta S is negative also? So here, delta H is negative and delta S is negative, negative, and here negative, it's positive. So in which case the answer will be negative? When the delta H is greater than temperature times delta S. So delta G is negative at low temperature. At low temperature, when you multiply temperature times delta S, you get small amount. So minus, here the charge of delta H is negative, and here it's positive. It's a smaller amount that delta G, so the answer is negative. Now, what about if delta G is positive and delta S is positive? Delta GH is positive and delta S is positive. So here positive, and here you have negative sign, so negative. So in which case the answer will be negative? When the temperature times delta S is greater than delta H. So in which case this will be greater than delta H? When you have high temperatures. So it's negative at high temperatures. Now, what about if delta H is positive and delta S is negative? Delta H is positive and delta S is negative, and here you have negative sign, so positive. When you add positive number to positive number, the answer is positive. So here, positive, always non-spontaneously reactions. So again, delta G equal enthalpy minus temperature times entropy. So when you add or when you subtract enthalpy from temperature times entropy, if the answer is negative, so it's a spontaneous reaction. If the answer is positive, it's a non-spontaneous reaction. Example, here, for a reaction, ammonium chloride decomposed to ammonia and hydrochloric acid at 300 Kelvin. Delta H is 175 and delta S is 0.3. Calculate delta G and tell whether this reaction is spontaneous in the forward direction or not. The rule is delta G, if delta G is negative, so it's a spontaneous reaction. If positive, it's a non-spontaneous reaction. So delta G is equal delta H minus T delta S. What about enthalpy of reaction? It's equal to 175 minus the temperature, 300, times the entropy is 0.3. So, which is equal 175 minus 300 times 0.3 equal 90. So, which is equal 85. So, delta G equal 85 kilojoule. It's a positive. So, it's a non-spontaneously reaction. Now, another example for the vaporization reaction, bromine liquid to bromine gas, delta H equal 30 and delta S equal 0.1. At what temperature will this process be spontaneous? Okay. Now, delta G equal delta H minus T delta S. So, at what temperature will this process be spontaneous? In which case, it's a spontaneous reaction when delta G is negative. So according to this rule, in which case delta G is negative when the temperature multiplied by entropy greater than delta H. They carry negative charge, so if they are greater than delta H, the answer is negative, and it's a spontaneous reaction. So, spontaneous reaction means delta G is negative when temperature times delta S greater than delta H. From question, delta H is 30 and delta S is 0.1. So temperature times 0.1 must be greater than 30. If you divide over 0.1, 0.1. So temperature must be greater than 300 Kelvin. So, when temperature above 300 Kelvin, when you multiply temperature times entropy, you will get greater number than delta H because they carry negative charge, so the answer is negative. It's a spontaneous reaction. So here the answer is temperature above 300. So again, factors that affect if the reaction occurs spontaneously or not, two factors, delta H and must be negative, and delta S, it must be positive. These two factors oppose each other. So which of these the dominant factor? So you have to calculate delta G. Delta G, it must be, you have to calculate delta G, and it must be negative. For negative, it's a spontaneous reaction. If positive, it's a non-spontaneous reaction. So this is the rule. You have to apply the rule and get if delta G is negative or positive.